Hello viewers, I am Kausalya. Today we are going to solve another problem in nodal analysis. The problem is find the power delivered by the 5 amps current source in the circuit shown in figure by using the nodal method. So here, where is the 5 amps current source? Here is our 5 amps current source. We have to find the power. So what is the formula of power? Power is given by two formulas. Either we can write it as I square R or it as VI. So in any one way we can calculate the power. So here, since it is clearly given that we have to use nodal method. Here how many nodes do we have? Totally we have 3 nodes. So now we are going to write the nodal equations. So as a first step here, I am going to combine the nodal equation for nodes 1 and 2 because only minimal elements are connected with node 1 and node 2. So here you see, to this one how many elements are connected? There is a current source, there is a voltage source and there is a resistor. And while writing the equation, we will reject this voltage source. Right, that is reject means we will frame a separate equation for this voltage source. And when you look at this node 2, again you see 1, 2 and 3 and again we won't consider this 10 voltage source currently. Right, so the combined nodal equation at node 1 and 2 are given as, so here this is your node 1 and you see this 2 amps current flows away from the node. Right. So here it is written as -2. And between node 1 and 3 we have a 3 ohm resistor connected. So how to write this as equation? We will write this as V1 minus V3 by 3. So now node 1 is over, right? V1 minus V3 by 3 is equal to -2. That is sum of currents flowing towards the junction is equal to sum of currents flowing away from the junction. Now when you look at this node 2, you see to this node 2, this 5 amps flows towards node 2, right? Therefore here we are writing it as +5 as this 5 amps is moving towards node 2. And here this, why here it is -2? Because this current flows away from node 1, right? And the remaining things are, again you see, 1 ohm is connected between node 2 and node 3. So here we can write this as V2 minus V3 by 1. And again you see to this node 2, 5 ohm resistor is connected. So here we have to write it as V2 by 5. So finally this is our equation, right? Combined equation at nodes 1 and 2. Right? So the next step is we are going to rearrange this equation. So when you rearrange this equation, you see there is only one V1 term. So here we are writing it as V1 by 3. And the next thing is we are combining this V2 because here we have two terms. So when you take V2 outside, the remaining things are 1 plus and here it is 1 by 5. And again here when you take V3 outside, here we have a minus sign which is common for V3. So I am taking minus V3. So the remaining terms are 1 by 3 plus 1. Right. Equal to, and 5 minus 2 is 3. Again when you solve these numbers, here we have equations like this. 0.34 V1 plus 1.2 V2 minus 1.34 V3 is equal to 3. Let this be our equation number 1. Now we are going to write nodal equations for node 3. So to this node 3, you see 3 resistors are get connected. So when you write equations for node 3 should be given importance, right? You have to represent this 3 as a first term. So here it is, you see V3 and this 2 ohm is connected between your node 3 and ground. So the first thing is V3 by 2. Now the second thing is V3 minus V2 by 1 and finally V3 minus V1 by 3. So these are all the different values. So you have to write like this, and there is no current source for this node 3. Right, only resistors are there. So here After writing these three terms, the entire term is equal to 0. And the next step is we are going to simplify these terms. So again combining the similar terms together, and when you simplify, here we have 1.83 V3 minus 0.34 V1 minus V2 is equal to 0, and name this as equation number 2. So here I believe you people know how to combine similar terms together. So here we have 3 V3 terms, okay, V3 by 2, V3 by 3 and V3 by 1. So when you take V3 commonly outside, the remaining terms are 1 by 2 plus here it is 1 by 2, here it is 1 by 3, and finally here we have a 1. So again when you sort out and simplify, finally we get the equation like this, and let this be your equation number 2. So now we are going to solve these two equations. So while solving the equations, always keep this thing in mind, and let us write the equation number 4 now. Right, then only you will get a clear idea. So here this 10 voltage source is connected between your nodes 1 and 2. When you write this in the form of the equation, you should write this as V1 minus V2 equal to 10. Why is it so? Because the positive terminal is connected to V1. So here you have to write this as V1 minus V2 is equal to 10. So here V1 minus V2 is equal to 10. Let this be your equation number 4. So why I am giving much more importance to this equation is you have to find another equation such that it contains only V1 and V2 terms so that we can easily solve. So if you want V1 and V2 terms alone, what is the term you should cancel? So you should cancel only V3, then only you can get equations in the form of V1 and V2. So just make this concept crystal clear. Okay, this helps you in easily solving the equations and finally getting the answers. So, because once you see these two equations, the first thing that comes in our mind is, you see, we can easily cancel these two terms. And finally, we will be ending up with equations having V2 and V3. But here we have only V1 and V2. Then how can we solve? This process will be a bit tedious. So, always look at this equation and then select which term to cancel. So here you see the term is here minus 1.34 and here 1.83. So now I am going to multiply this equation 1 with 1.83 and equation 2 with 1.34. So once you multiply, you see here these two terms get cancelled, and finally here we have equation like this. So here there is no need to change the sign of the lower terms, just we are adding, because one is with minus sign and another is with plus sign. So when you cancel these two terms, finally we have 0.1666 V1 plus 0.856 V2 equal to 5.49, and this is your equation number 3. Now we are going to solve equations 3 and 4 to get V1 and V2. So when you observe keenly, whenever just you multiply, you have to multiply either with 0.856 or 0.1666. Now I am going to multiply this equation 4 with 0.1666 V1. So when you multiply, here we have this equation, and now we are going to solve equation 3 and equation 5. So here we are doing a subtraction. So just we are changing the signs of this equation. So plus becomes minus, minus becomes plus, and again here plus becomes minus. So here what happens, these two terms they get cancelled, and when you simplify this term, here we have 1.0226 V2, so which is equal to 3.824. So now what is the value of V2? V2 is given by 3.824 divided by 1.0226. So finally here we have the answer 3.7394 volt. Okay, this is your value of V2. Once you substitute this value of V2 in equation 4, then we can easily calculate the value of V1. So you see I had done the same, and finally the value of V1 is 13.7394 volt. Now we have calculated the values of V1 and V2. So when you substitute these two values in any one of the equations, right, either in 1 or in 2, then we can easily calculate the values of V3. So you see here I have selected the equation 2, and when we substitute V1 and V2, the value of V3 is given as 4.596 volt, and this is your value of V3. So here we are asked to calculate power delivered by the 5 amp source. So here the power delivered, we are choosing V into I, and here in this case when you look back at the problem, this 5 amps is connected with node number 2. So what is the value of V2? V2 is given by 3.7394 volt. So here the value of V2 is 3.7394, and what about the current? The current is 5 amps. So when you multiply, finally we end up with 18.6970 watts. So this is the power delivered by the 5 amp source. So that's all. If you have any doubt, let me know in the comment section. Thank you.